Hi everyone, welcome back to the channel. In today's video, we are continuing our GeoPandas series. This is video number 4 in the series. We will be diving into Pandas Series, one of the core data structures in Pandas. By the end of this tutorial, you will understand how to create, manipulate, and analyze series data. So let's get started. Before we jump into Pandas Series, let's quickly revisit what a data structure is. A data structure is simply a way of organizing and storing data so that they can be accessed and used efficiently. In Pandas, there are two primary data structures. We have the series and the data frame. Today we'll focus solely on the series. What is Pandas Series? A Pandas series is a one-dimensional data structure that can store data of any type, whether it's integers, floats, strings, or even complex numbers. You can think of it as a one column in an Excel spreadsheet, or a more powerful version of Python list. So let's jump over to our Jupyter Lab and create our first Pandas series. We'll start by running this import pandas cell to instantiate our pandas throughout our notebook. So you can do that by Control and Enter. Now that is done, we'll move to creating an empty series. So to create an empty series, all we need to do is call our series constructor without any arguments. So when we run this cell, as you can see, a series has been created with an empty list. There are a couple of ways to create a non-empty series. We can do it by passing a list or a dictionary as arguments to the series constructor. So let's look at how to do that with a list. To create a series from a list, we'll first create our list data and then pass it as an argument to the series constructor. As you can see here, we have 2 rows instead of 1. This one, the row on the left hand side, is a default row that Pandas always creates when you create a series or a data frame. We can just print the values and then the index. So when I run this code, you see here we have just the values. That's the list that we passed. And then here we have the index. So by default, the index is an iterator from 0 to the length of the list or dictionary that you passed into your series. Even though by default, Pandas creates an index for you, you can create your own meaningful index. So to do that, we'll create a list of the same length as our initial list values. And this is going to be our index list. And then we can pass it into our series constructor as a custom index. When we run this cell, we see that the index, the numerical index that we had, has been replaced by our custom index. Another way to create a series is by passing a Python dictionary. In this case, the dictionary keys become the series index automatically. That's because Python dictionary by its very nature is a key value pair. So it makes sense that the key of the dictionary becomes the index of your series. Just like with a list, you can also create your own custom index if you don't want to use the keys of the dictionary. We'll move to selecting elements in a series. We can access individual elements in a series by using either the index label or the numerical position of your series. Now, if you didn't essentialize your own custom index, then the numerical position is the default. If we want to select multiple elements, we can slice a series using either the custom index labels, or we can use the position of the element. If we've talked about how to select elements, then the logical extension is if you want to update values from a particular element. All we have to do is just assign your updated values. Pandas also support arithmetic operations, but we should keep in mind that the data should be numerical when we are performing arithmetic operations with Pandas. So we've created a new Pandas with a list, and then we are dividing all the elements in the Pandas by 5. We can also perform arithmetic operations between 2 series. So we've created series 1 and series 2, and we are adding 2 of them together. So let's say we add a fourth element here, and we run the cell. So you're getting none value. Usually we encounter none values due to either messing on invalid data. So in our case, we're adding a number to a number that wasn't there, so the data we had was invalid. That's why we had a none in our previous example. But sometimes when you're dealing with real life data, sometimes the data is just not available for some reason. And in that case, you might also get none values in your data. So none values is an abbreviation that means not a number, right? And I think Pandas handles that as a float in memory. So here we create a series with none values here. And when we run this series, when we print it out, we get the none values. We can also check for none values in our data using the is null or not null. When we are using the is null, we are going through the elements in the series and then we are asking, is it null or not? If you are the inverse, you can use the not null. We can filter our cells based on conditions. So from the previous example, we can use the result from the not null or the is null function that gives us true or false depending on not if the element is null or not, right? The output of the not null is also a series, but it's a series of true or false. So we are inserting the series into this series. And when we do that, we can filter out based on that condition. Whenever a value is true, it is going to give us the output. So here we can see that the output gives us output that are not null. We can also filter based on numerical conditions. And then we are checking the individual elements in the series if they are greater than 3. And then we will just have only one value that's greater than 3, which is 4. So yeah, that's another way to filter our series. We can find unique values in a series with a unique function. So from series from list, if we have a series with duplicate values and we just want the unique values from the duplicate values, we can use the unique function to just give us only the unique values from the list of data that we have. And then we can also use the value.count function to count the occurrences of each of the values in our data set. In this case, the series that we are using doesn't have duplicate values. So the last session that we'll be looking at is check for membership. We can check if specific values exist in a series using the isIn function. So with the isIn function, we have a list of functions. We are checking if those lists are in our series from list. And just like the isNull or not null functions, we can use this output as further conditions for filtering. So that will be a wrap for today's video. We've covered the basics of Pandas series, from creating to manipulating them. I hope this tutorial was helpful and then it helped clarify Pandas series. In our next video, we'll explore Pandas data frames. So be sure to hit the subscribe button so you don't miss it. Don't forget to like, share, and subscribe. If you have any questions or topics you would like us to cover, you can drop a comment down below. Thank you for watching. I will see you in the next one. Stay practical.